Morning friends. Today we will go for module 5. In that first I will complete steam nozzles because we have completed vapor power cycle. So there we have used a steam as a media. Here also steam is a media through nozzle. So nozzles we'll see. Similarly we are going to use that steam tables only to solve the problems. So I think it will become continuation, and we will start the module. So steam nozzle, what all we have to cover? Flow of steam through nozzle, shape of nozzles, effect of friction, critical pressure ratio, and supersaturated flow. In this is very limited portion. So he may ask you explain the flow of steam through nozzles, explain the shape of nozzles, explain effect of friction, and derivation critical pressure ratio. If we want to ask, there is only one derivation, that is critical pressure ratio, and supersaturated flow will be we are studying in the flow of steam through the nozzles. So this is a very easy and marks gaining chapter. Sometimes in earlier question papers I have seen full 20 marks is asked on steam nozzles only, and if they are shuffling, minimum some 10 marks are asked on the steam nozzles. So in two question papers they have shuffled, in two question papers they are not shuffled. So to be safer side, to gain the marks in the VTU exam, you can you cannot skip a single point in the steam nozzles, right? We'll start the model. First of all, which point we'll study? We'll study what is nozzle, right? So nozzle is a passage of varying cross section which fluid is accelerated to a high velocity. So you know already the figure, this figure, this is nozzle, right? So initially whatever steam we are sending, it is having high pressure, but to impinge on the blades we required high velocity. High velocity means high kinetic energy. So pressure energy needs to be converted into kinetic energy. So which device we need to use? Then we need to use nozzle. So here steam nozzles we are studying. Steam nozzle particularly converts heat energy of steam into kinetic energy, right? So applications of steam nozzles are, so it is used in the steam turbines. If you are using in the gas, it is as a steam as a media, gas turbine. Steam flow meters, ejector for removal of air from the condenser, injectors for pumping feed water to the boiler. Means in the boiler feed water, if you want to inject the water, so injectors with these nozzles only they are going to use, right? So types of the nozzle. So there are three types of the nozzles. One is convergent portion, second one is divergent portion, and third one is convergent divergent portion. So these, if you have studied in FM, if you want to see the nozzles, you can go to FM lab whenever you are free. Then observe for every turbine there is a nozzle. And if you want to see the convergent divergent portion, you can see the venturimeter again. So it acts as a nozzle here, right? Means it has a convergent throat and a divergent. So as you can see in this figure, there is a entry means from here only we should supply high pressure low velocity steam. Initially whenever we are sending, here we have high pressure and low velocity steam, but when it exits we have low pressure and high velocity steam, right? So these cross section decreases, you know, this very simple, this one this one, the nozzle. So it has a decreasing cross section from entry to exit. As steam flows through the nozzle, its pressure drops because area is decreasing, velocity is going to increase. You also have the continuity equation, a1 v1 is equal to a2 v2. So I will just see here. So if I take pen, I will take just pen. continuity equation is what? A1 V1 is equal to A2 V2. So A1 V1, you are decreasing this, and what you are doing? A1 to A2 you are decreasing, means area is decreasing, and this velocity has to increase, so it has to be equal. If this is going to decrease, this is going to increase, because this is decrease, this is increase. Because if you want to make it equal, you need to reduce the area, increase the velocity. That is continuity equation. Here it is going to apply, right? This is how so many people can ask, if I pass through the convergent portion, what will happen? Why velocity should increase? This due to continuity equation. If you substitute the values, you will get the velocity increased, right? So it is useful in the application requirement up to 0.58 when using saturated steam, right? So some applications are given here. Next we'll go for simple one more. This one is divergent nozzle. So this type of cross section divergent nozzle means increase in the continuity from entrance to exit. It is used to in a case where back pressure is less than the critical pressure ratio. So this type of this one is, we are also calling this as draft tube. Draft tube, this is used in the Francis turbine. So this is while supplying the steam, these are not used. While exit of the steam, these are used. Means to drag out the steam outside, we need to use this divergent nozzles. So convergent divergent nozzle, it is one of the important nozzle. Here I have drawn again. So entry is this, throat is this, exit is this. So this is convergent portion. This is throat area, means exactly where there is a vena contract. So this is throat, then exit. We have the convergent portion, divergent portion. Both are combined here. So as to get the advantages of both the nozzles. The cross section initially decreases and from the entry to throat, then increases to the exit. In convergent section, the steam pressure reduces, resulting in increasing velocity. Here increase in the velocity will happen, but steam still it is in the form of wet steam, or it is still in the form of high energy only. So if you let it out, it will go as a waste. So if we add divergent portion, so we will allow it to expand further into the divergent section and get the increased acceleration. So as the steam passes, in addition of divergent part, the nozzle after the throat is necessary in order to allow the expansion of the steam to take place and to obtain further pressure drop and acceleration of steam. So we have there is one number like Reynolds number. There is one constant called as Mach number. So this is dimensionless number. This is the ratio of speed of fluid to the speed of sound. So what is speed of sound in air is 343 meters per second. Suppose in the convergent portion, whatever velocity we are having, it is subsonic, and at the throat it is sonic, and at the exit or in the divergent portion it is supersonic. So at sonic velocity, Mach number will be equal to 1, means speed of sound is equal to speed of fluid. If speed of fluid, whatever your steam you are supplying, if this velocity is less than sound velocity, then it is called as subsonic velocity, right? After passing through the throat, its velocity of steam will be higher than the velocity of sound, then it is called as supersonic. That Mach number will be more than 1, right? So Mach number more than 5, it goes 5, then it is called as hypersonic. Further part you are going to study that. So these are the 3 types of nozzles, right? Next we will go for types of flows. So types of flows, there are 3 types of flows. One is frictional adiabatic flow. Second one is frictionless adiabatic flow, frictional adiabatic flow, and supersaturated flow. So these are very simple type of flows. Means here frictionless means we are neglecting the friction and we are considering purely ideal and adiabatic flow. Here considering friction, we are taking the friction into account and calculating the velocity of fluid. And supersaturated flow is new one, it is called as metastable flow. I will explain now one by one. So flow through the nozzles, we have frictionless adiabatic flow. Means suppose this is HS diagram, again it is a Mollier chart. We have pressure, these curves are called as saturated line, and this is these curves P1 P2 like this, they will be there in the Mollier chart. And from 1 to 2, if I pass from one section to 2 section, here it will be purely isentropic and purely straight line, because we are not considering the friction between the steam and wall, friction between the layers of the steam. So these all things we are not taking into the account. So it is here I have written, it is assumed that nozzle does not cause friction between walls of the nozzle and mass of system. So pure adiabatic expansion occurs from boiler pressure to exit pressure. So next one is frictional adiabatic flow. If I take frictional factor into consideration, this dotted line will be the actual case. So here x2 is the quality of steam, at x2 dash it will become the quality of the steam now because of friction. What is friction? Friction is the resistance for the flow. When it resists the flow, there is a friction. Friction means there is heat generation. Suppose if heat generation, if I am saying it is heating of that steam, because of that friction we are observing in the HS diagram that 2 is increasing to 2 dash, means quality of steam is increasing, but the pressure is also decreasing, and pressure is same, but quality of the steam is increasing, right? So it takes into the account of friction produced between walls of the nozzle and mass of the system. This friction causes resistance to the flow, which is converted into, due to this dryness friction is going to increase. Here already I have explained, right? So one more this one flow is supersaturated flow. Supersaturated flow, just I will just explain. So this is the type of HS diagram. So that is saturation line, and one more line is drawn as x is equal to 0.96, that is Wilson line. So what we are assuming, dry saturated line, also we have solved problem in the vapor power cycle, that if it is given dry saturated, I was taking x is equal to 1, that is 100% I was taking, but in actual case it never reaches 1, maximum it can reach up to 0.96 according to Wilson, who is the scientist, and he has drawn the dotted lines below that. Why that happens? See, this type of flow occurs in the divergent portion of convergent divergent nozzle. So in the convergent divergent nozzle, what I said, in the divergent it is going to expand, and what we are thinking, whole steam is going to condense to the liquid, but some portion in the due to rapid expansion, steam does not have time to condense. It remains unnatural, dry or superheated state only. This type of flow is called as supersaturated flow or metastable flow. So the main effects of supersaturated flow are entropy and specific volume of the steam increases, exit velocity of steam reduces. Because of this problem, there is a reduce in the velocity of steam. Dryness fraction increases. For the same pressure limits, enthalpy drop reduces. So these are the effects. So here note I have written, Wilson line represents limiting conditions of undercooling at which condensation commences, and it is assumed to restore conditions of normal thermal equilibrium. So this is the one of the important flow. This is so many times asked in the exam for short note for 4 marks or 3 marks. So kindly study this. We will stop here in this video and I will continue in the next video. Thank you.